Okay, loose fibrous connective tissues. Loose fibrous connective tissues is the first type of connective tissue we're going to talk about. They support epithelium and many other internal organs. They form protective covering. You can find them in basically almost all types of organs: muscle, blood vessels, nerve, lungs, artery, urinary bladder. And an example of this loose fibrous connective tissue, we call it areola. Areola is, we also call it connective tissue proper. It has all three types of fiber. As we mentioned previously, connective tissue has two components, the connective tissue cells and the matrix. And inside the matrix, we have three types of fiber: collagen, elastic, and reticular. And this areola has all three types of fibers. And then dense connective tissues. Dense connective tissue, as the name suggests, it is dense and it is tougher, stronger. Why is that? Because it has a lot of collagen fiber in it. And then an example of this dense fibrous connective tissue, they form tendon and ligament. What's the difference between tendon and ligament? Tendon connects muscle to bone, but ligament connects bone to bones. And both loose and dense fibrous connective tissues, they have fibroblasts. Fibroblasts, whenever you see the word blast, blast B goes with born or giving birth. Blast. Born or birth. So what does it born or what does it give birth to? Fibro. Fibro means fiber. So this kind of cell, fibroblasts, they will give birth or they will born the fiber. So this kind of cell, fibroblasts, they will make collagen, elastic fiber, and the reticular fiber and such. So loose fibrous connective tissues, this is a picture of areola. Areola, the pink thick one is the collagen, and then you have this darker black one. These are the elastic fiber, and they should have reticular fiber. Maybe this one is the reticular fiber, the thinnest one is the reticular fiber. So or they cannot see it, it's too small. And then the dense fibrous connective tissue, they form the ligament and tendon. All these are the collagen fiber. And then you have adipose tissue. Adipose tissue is basically our body fat. Our body fat. Adipose tissue, you have the fibroblasts enlarge and store fat and become adipocyte. So the cell, it has a specialized vacuole that can store fat. The vacuole actually stores so much fat that it enlarges and occupies the entire cell, and so that it pushes the nucleus of the cell to the side, to the side of the cell. We use the adipocyte, adipo mean fat, site means cell, that means it's just fat cell. For energy storage, insulation against heat loss or gain, organ protection. We can find body fat under the skin, around the kidney and the surface of the heart. We can find a layer of fat around kidney because kidney, they are located at the back under your rib cage, which is not protected by the rib. We can say partially exposed to the outside of the ribs. So your ribs only partially protect your kidney. So that's why your kidney has a layer of fat as a protection. So as you can see that this is your fat cells, adipocyte. You see that this is the nucleus. This is the majority of the adipocytes. They are the vacuole filled with fat, and then they push the nucleus to the side of the cell. And then last time, you have the reticular connective tissues. Reticular connective tissues, they form the lymphatic tissues. They form lymphatic tissues. They found the lymph nodes, spleen, and thymus, and bone marrow. All these are the lymphatic organs. So reticular connective tissue, as the name suggested, they contains reticular fiber, which is the thinnest, weakest of the fiber. So the reticular connective tissue, they are very weak and soft, and that's why we use that to form your lymphatic systems. Cartilage. Cartilage is an example of dense fibrous connective tissues. And this cartilage dense, they have smooth surface, allow bones to glide on each other. Basically, it reduces friction. It reduces friction as the bone move on each other, when it glides on each other. The cell of the cartilage we call chondrocyte. Chondrocytes are the cartilage cell. Chondrocytes, they bathe in lacuna. It's like they are bathing in a jacuzzi. Lacuna is like the jacuzzi for the chondrocyte. They bathe in the lacuna, and then they also have the matrix. There are three types of cartilage: hyaline, elastic cartilage, and fibrocartilage. We have three types of cartilages. Okay, we have three types of cartilage, and then we have we briefly go over the three types. So so let's talk about elastic first. Elastic, as the name suggests, it has a lot of elastic fiber, making it flexible and stretchable. It forms an ear, or we can call it external ear. You can see that E goes with E. So this is how you memorize it. The elastic cartilage form your external ear. So both are E. External ear goes with E. And then fibrocartilage. Fibro. That means it has fiber. Fibrocartilage, it has fiber. Why is it so important it has fiber? Because it is the strongest cartilage. It has the collagen fiber that makes this fibrocartilage very strong. You can find fibrocartilage in between vertebrae. When you walk, every step that you take, you will make your body move up and down a little bit. And because of that, your vertebrae at the back of your body, let's take a look at this model here. So the blue, these are the fibrocartilage. Every step that we take, or not just we jumping of course, but even if you are walking on the flat ground level, there will be impact between each vertebra. So they will compress each other, and it is because of the fibrocartilage here that absorb the shock. Also, we have the fibrocartilage here. in between the hip bone. This fibrocartilage is called pubic symphysis. And also we have fibrocartilage in between the knees, so that when we walk or when we jump, the femur and the tibia, they will not hit on each other directly. Instead, there's fibrocartilage here to absorb the shock. So last one, hyaline. Hyaline is basically all the rest of the cartilage you can find in your body. For example, the cartilage in your rib cage, they are the hyaline. The cartilage that form your nose here, this is your hyaline. So that's why when you compress your nose and when you relax it, it can go back to its original shape because these are the cartilage, the hyaline. The rest of your bodies, the cartilage, they are all hyaline. And also, they said that the nose is a hyaline, the ribs is a hyaline, respiratory passages, that means here. So if you hit people's neck here, it can cause the trachea collapse because there are rings of cartilage here. The rings of cartilage here, they are the hyaline and also fetal skeleton. Before the baby is born, when they are still a fetus in the uterus, all the bone are there hyaline. They have not gone through the ossification yet.